Well, thank you, Willem. We're just getting used to this new studio here that we're doing, and so yes, James was supposed to be talking about 3D printing. He is the clickbait that we put on this talk, and you ended up with me. I think this is the definition of James as the clickbait. You ordered an Uber, but you got a goober in exchange. So what I did is, what can we do? And by the way, James, it is a family issue. He had to fly. He is okay. It's not like he fell off a tower or something, but he's got a family member that's really in need of some care right now. So he'll be back with us shortly. And so Mark Skelton used to always joke with me, oh, you're going to prepare your slide deck the night before. Well, that's not the case with this talk. I prepared my slides this morning because I only had about 24 hours notice on this, and I was busy working all week. So we're going to throw something together, but I think it'll be interesting. There we have the call slide. When John Maxwell called me up and said, what can you do? And I said, well, and he said, can you do something on filters? So I said, okay, I'll do something. I've got some stuff that I could throw together. But I kind of decided that really what I'd like to do is a continuation of a really good talk that Bob Whitty, K0NR, did for Rocky Mountain Ham University, where he said, here's some voltmeters, some spectrum analyzers, network analyzers, and it was a really, really good talk about these pieces of equipment. So what we're going to do is turn this less into a lecture and more into a lab course. And you can see the side view, and we'll later have some front views of the test equipment. How can you use this to do something useful? And I made a very detailed lesson plan. I scribbled it on a piece of notebook paper. And we're going to talk a little bit about using the network analyzer, but we're going to compare it to the nano VNA that some of you may have. We're going to kind of compare to the spectrum analyzer. And how can you use this equipment to do something useful in your ham shack? So we'll talk a little bit about, I wrote down here, S parameters. What is the S parameter? And the way they've done this, well, you're just going to have to live with it. We'll get to it later, but S parameters, and what do these mean and what can be useful? I did bring a number of filters. And I brought, yeah. And guys, the tech crew is doing a great job, but they've changed the setup a little bit. So I'm over here, I guess. They've changed the setup a bit, so we're still kind of getting used to which camera do we switch to and such. So I brought a piece of a 40 meter, 20, 15, and 10 tri-bander with the 40 meter add-on kit that we really worked on over field day that I thought was an interesting experiment. And on the table in front of me, I have a duplex filter, a duplexer, that I very frequently get on the, I get the question on the, I guess we're over here now, get the question from the Hamfest, I just bought this duplexer. Can you tune it so I can use it on my repeater? Well, this is fresh from the Hamfest. You can still see the dust on it. I have not connected to it to see if it's a good unit or not. We're also, as well as it is Oktoberfest, but sparkling water. I brought some isolators and things that, they're moving cameras on me rapidly, so sorry about that. I don't know where they're pointing at me. I brought some isolators and some antennas and other filters. So we're going to use our network analyzer to figure out how to do this. This is also going to be interactive, so I'm going to ask the tech crew here to unmute the phones. If you're not speaking, though, please mute yourself, and if need be, we'll do it for you. But so you're welcome to chime in the chat window. You're welcome to chime in on audio and talk with us. So, and I hope this is of interest to people. I know we did have a little bit of a problem with the access code, but we have Dave, Mark, and Mark back here. Do we have some people online? And I guess we're, okay, 13, okay. We had, I think John told us we had 60 people registered. And I said, well, it is a pretty big clickbait, bait and switch. I'll be happy if we hit double digits. So thank you for being here. So with that, Dave, do we have the plagiarized slides from Bob Whitty that we can do a brief review? And let's see what the next slide is. So yeah, while he's working that, we kind of said we're gonna lobby Willem to kind of have, as part of the tech talks, the bench side chats with various people, and this is kind of the new title: Useful Tips and Sample Projects Using Your Network Analyzer. He's working it, so. We will have some breaks. If you're looking for the nearest sanitary facilities, you're on your own because you're in your home. I hope you know where those are. We have the cat's litter box close by, so if needed, we'll use that. There will be some breaks. There will be also, we're going to try to time one of the breaks with the solar eclipse. That's, I think, they said it's going to be peaking at about, what, 10:30? So, and I forgot my eclipse glasses, so we just won't look directly at it. And, well, if Dave was able to get the Bob Whitty slide up. Oh, there we are. This is one that I've stolen from him before, and it's Bob's first law of electronic measurement, and I love this. With electricity, most of the time, we cannot observe what is going on without measurement instruments. His second law, when we can observe it, and if we can go back, okay, when we can observe it, it's usually a bad thing. So one of the things we're going to talk about today in our presentation is the activities we had at Field Day, and I'm hoping that Willem will chime in a little bit because we had two major projects, and I'm getting text messages. Is that okay? That's from somebody else. Just making sure it wasn't somebody on here saying we were wigging out on our feed. We had an issue at Field Day with a tri-band Yagi and also with a multi-band vertical. And we used the equipment that you're going to see on the bench here directly for that. And then we're also going to observe what's going on in a filter. So, but I love this from Bob. If we go to the next slide, Dave. This is one of his charts that says, well, here's how we're looking at, and he's kind of got a spectral map here. And the only thing he didn't do is continue beyond UHF to SHF or USHF. But in his original talks, he talked about AC and DC. We're not talking about that today. We're really not even getting into modulation And so we are going to move toward, we're getting the bugs worked out here, guys, so thanks for sticking with us. But we're going to talk about VHF, HF, VHF, and UHF, specifically on the spectrum analyzer. So his next slide was a Agilent or Keysight, used to be HP, network analyzer. I'm got one here. It's a little older model, and we don't have to go to the slide, but if we can switch to Mark's camera, or maybe we're not on Mark's camera. There we go. Up on the top of the tower here, we've got a Hewlett-Packard. So it's very old because it still has the HP logos. 8753D network analyzer. This unit works from 30 kilohertz to 6 gigahertz. When this was made and manufactured and sold by HP, probably this is, what, early 1990s? Maybe late 80s. My guess is this unit, when it was new, probably cost $20,000, maybe more. And it is, you can pick these up at your used test equipment dealer or even on eBay if you know what you're buying, for as little as $3,000 to $4,000. And it's big, it's heavy, but boy, is it a nice instrument if you're trying to do things. So we also have on our bench if my camera crew goes back to Mark's camera, we have just down here, Mark, a portable unit that this is the one we actually used at field day. We can go back up top here, Mark. It's the one we actually used at field day for some of these measurements. You'll see all these little trinkets, and if we go back to Mark's camera, all these little trinkets up here. This is not just junk that I've accumulated on the bench. It is part of this Hewlett-Packard calibration kit. And inside of here are all these little terminations, shorts, and opens. That's an open circuit because it's hollow in the middle. And that's what we call, it's what's known as the cal kit. So we're going to be using those, and we're also, I'll get it later. I was thinking the open load short, but we'll get that later. So this is what we're going to be working with today. And if we switch back to Bob's slides, and the next slide, please, will have, I believe, so we're talking this large network analyzer, but I think the next slide is Bob talked about the nano VNAs, and those are very good units to have. They're affordable. I don't know the exact price class. I guess we can't get to the next slide, can we, Dave? Or okay, he's working it. The nano VNA, and I don't know if we have the microphones open, but if people on here have a nano VNA and you're unmuted, you're welcome to say, hey, I got one, and we kind of compare to this big unit that I'm working with here. But my impression is you can get these things for starting around $100. And they're pretty crude at $100, but for $250, my recollection is you can get a pretty nice nano VNA. And that's a good instrument, but it will get better resolution on this lab grade benchtop instrument. So I think people know the nano VNA. It's a little small piece. It's got a little tiny LCD screen, and a couple of ports on it that are somewhat similar to this, but a little different, and you can get some pretty decent measurements with that unit. And we're actually going to talk about that a little bit later when one of our members, Tristan Honscheid, NM0TH, who I had hoped would be with us, but he's actually doing something really fun. He's out camping in Moab this weekend. As we say, we didn't know we were going to have this today, but he showed up at a ham fest with one of these little mobile UHF duplexer units. And you've probably seen these, and you may have one, your club may have one. And he bought one, and he was using it on the repeater that he has in his basement that he uses for test and development. And he wanted to have one antenna on his repeater going through. And he tried tuning it on his Nano VNA, and he said it didn't work. And he shows up at the ham fest and says, can you make it work? And I said, well, okay, you got the filter. What am I going to tune it with? And he reaches in his other pocket and he pulls out his Nano VNA is about the size of an iPhone. So he pulls this Nano VNA out, and I looked at him and I said, well, I got a filter. I got a Nano VNA. Did you bring the cables? He pulls out the cables. Did you bring a 50 ohm load? He pulls out a 50 ohm load. So we set up at the table at the ham fest, and everybody's coming by saying, how much you want? And no, we're not selling it, we're tuning it. So we're hooking up to this thing, and I've got this little mini Nano VNA, and I'm trying to get my finger on it, you know, and he looks and he goes, and he pulls out another, would you like the guitar pick that we use as a stylus on these things? We tuned up his filter right there at the ham fest using a Nano VNA, and everything he had was in his coat pockets. That's pretty incredible, because when I started as a new ham, I got my license in 1977. I was in junior high school. We didn't have this kind of thing. I didn't even have this network analyzer. What we can do today for $5,000, we'll call it, and what we can do today for under 500 with a Nano VNA is absolutely mind-blowing, at least to me. So did we get the other slides, or should I just wing it?
So the cheapo Nano VNA on Amazon is $55.
55. And how much is it, Willem, when it's nicely appointed? Or nicely
It's hard to
equipped?
judge the
That's what they say
quality
in the
from the
cars.
Amazon website. So there are some kits for about $150, but
Okay.
I think that's more the accessories rather than the instrument itself.
Okay. I seem to recall if you really want to go the gold standard of Nano VNAs, $250 you can do an awful lot with. And you can do some decent measurements at $100.
I think that's the version 4, and that seems to be around $100 or so now.
Okay.
Or at least that's what I've seen on Amazon.
So if you want a big keypad and everything, as we're going to show you, great. If not, you can get the Nano. There's even PC software, so you don't have to work it with a guitar pick. But it was pretty easy. I don't know the user interface on the Nano VNA at all. I can practically touch type on the Hewlett-Packard here. But I was able to figure it out generally, and what I couldn't, Tristan was like, oh, just pull this down, do this, this, and this, and he had it configured in seconds. There we go. So that's the Hewlett-Packard. This is this would be Keysight now. So in the beginning, it was Hewlett-Packard. They sold the test and measurement when they split to computers on one side and test and measurement on the other, to Agilent Technologies. Agilent sold to Keysight. I think it's still Keysight, isn't it? Do you know, Dave? Yes. It's still Keysight, and excellent equipment. This is a late model, and Bob Whitty was, I believe in his career, was with this test and measurement division. So also his first love of test equipment is this is also my first love of test equipment. And you never forget your first love. So the next slide. For some reason in the presentation mode, it's not doing, maybe we've just got to go to, yeah, and we can deal with that. So here are some pictures of those nano VNAs that Bob had. And I really don't know why this presentation isn't working. But we're not going to stick with these very long. So those are some of the nano VNAs. If you want really details, go back to, yeah, it's, don't worry about it, Dave. We'll just make it as big as you can, like you've got it there. And then the next slide down, perfect. So if you want to see really about the nano VNAs, go to Bob's talk. It's on the RMHAM website under past presentations, and it's, I believe, was it December 2022 in the time reference. This slide here, perfect, Dave, is from Bob's presentations. This talks about a 2-port network test and S parameters. And one thing I'm going to promise you, I'm not, other than maybe I'll show you on the network analyzer, I'm not going to do any Smith charts. I don't want to blow up my brain. I don't want to blow up your brain. But Smith charts are wonderful things. And I remember a book entitled, Who Was Philip Smith? He's the gentleman that invented the Smith chart. And the follow-up title was, And Why Are We All Afraid of His Wonderful Chart? But when you get good at what we're doing, you're going to want to keep learning about Smith charts and how you can get from one impedance on a circuit and match to another. But that's not where we're going to go today. But we are going to talk about these. He's got it on the lower right, S11, S21, S12, S22. And some of you may go, I got it. I got it, Doug. Move on. Others of you are going, what the hell are you talking about? I'm going to show you on this instrument. So I'm going to reference S11 and S21 a lot in this, and that's all a matter of which ports on my network analyzer, which ports on this device I'm looking at. And he's got the little circle here around the left. We'll get into that. The next chart down that we're going to talk about and is, so this is if you're running a nano VNA. The nano VNA doesn't have all of the capability of this Hewlett-Packard device because this device is actually able to switch which of the channels is transmitting and is receiving. There's a very complex, I think they're relays, or solid-state switch network. But I know there's some relays in here because I can hear them click when I push the buttons. And it's changing the perspective of the instrument. What am I transmitting out through and where am I receiving on this 2-port network analyzer? And the next slide down before, and I think we're done, is Bob talked a little bit about, I have an antenna. Well, I have an antenna here. It's a little quarter wave ground plane that was here. Okay, you can kind of see it against the purple shirt. I built it on an end connector. I have an intentional frequency that it was supposed to radiate at, and it's just some bus wire and some solder. My intent was that this was tuned for 918 so megahertz. Let's see how good I did. I built this thing, I just estimated, and then I hooked it up to my radio. I accessed the repeater I was trying to get to. I never bothered to sweep it, other than, yeah, the SWR was okay. So we'll get into that and do some measurements. So, okay, we're at 9 o'clock. just pacing ourselves. So what we're going to do today is start with a few of these filters and what we can do for measurements. What is our, when do you want some breaks? I'm looking to Mark and Dave and or Willem remotely. 9:30, so why don't we go into a little bit with the network analyzer. I'm going to spin you around and put it on here. Now I have pre-configured this network analyzer, but when in doubt, there's a button here, and it's green on a Hewlett-Packard or a Keysight, and it's marked preset. When in doubt, that's the reboot button. And you can see we're booting up, and now I have a fresh network analyzer. This device has the responses that we can do in this quadrant, which channels, and I'll explain the channels, the stimulus, the entry keypad, and instrument state on it. And we're going to go over a very high level, and I'm going to try to make it not too complicated, because when it's too complicated, come on guys, it's not going to work. So we're going to go through the simple. On the bottom of this thing is the ports of the network analyzer. So note port 1, port 2. That's going to be important. On my port 1, I always customize with this cable. I put a little red tape on each end. And this is just a short end-to-end cable. It's blue coax. It's made by Huber Sooner, a very reputable manufacturer. And if you peel back these things, I really don't know why they named it as such, but the brand is SUCO Flex, Succo Flex or Suco Flex. It is not a sucky cable. It's a really good cable. These are phase corrected such that as you move them around, you see minimal movement of the phase and the impedance of the cable. The other thing is if you buy one of these really nice network analyzers, and if we go back to Mark's view, I've taken this off and there's a connector on here, and I don't know if Mark can zoom in on this, this connector right here, but to those of you online, you're probably saying, well, that's an end connector, but that's not an end connector, and I'll give you a side view of the mating connector here. Does anybody know what kind of connector that is?
It looks like the microphone connector on an old Harley Crafters.
It does look a little bit like, and Mark here in the local audience, I don't know if he was picked up on the mic. Yeah, he says it's an APC7, and that's exactly what this is. It is, I guess I've heard it called a hermaphroditic connector. It is sexless. And depending on, there's a little ring here that you can run up and down, and you basically just, it's constant impedance. These are all constant diameter tubing sizes. So you just place it on here and hand tight, never pliers on these. And this is an adapter to a type N. Then my Sucoflex goes on. And you're sitting here saying, Doug, these are wiggling. Connectors aren't supposed to wiggle. These do. That's the way these are built. And as we're looking at various things on this unit, you're not going to see a lot of movement. Well, what you're seeing is my movement here. But this really is valid. So what we're doing is saying we've got port 1 and port 2. now we've got to sit here and say, where do I want to measure my circuit, my device? If this is an HF antenna, this thing does go down to 30 kilohertz. I'm going to say, well, I want to look at 3 megahertz, maybe to get 80 meters, and I want to stop at 30 megahertz because I want to see 10 meters. You can do that. So you just, if we go back to the other thank you, tell us our stop and start frequencies. Why don't we set up to look at this Hamfest filter, or no, I'm going to go for this 900 antenna. We're going to do a single port measurement. So I'm going to say, well, I want to start at 800 megahertz, and I want to stop at 1 gigahertz. So now you can see in here, I'm sweeping from 800 megahertz, stop at 1 gigahertz. If I say, what's the center? It's obviously going to say 900 megahertz, or the span is going to say 200 megahertz. Okay, the math works. It's not fuzzy math. No fuzzy math here. So I'm sweeping from 800 to 1,000 megahertz because I'm targeting this little antenna, I hope. Oh, there's a good, with the background view. 900 megahertz, plus or minus. What you see is a red line, and that's my reference, and you see a yellow line, which is the which is whatever I'm measuring. Right now I'm measuring S11. So I'm transmitting out port 1, and I'm letting whatever signal goes to the end, and I'm receiving back port 1. But I haven't calibrated this out yet. You can do uncalibrated measurements. We can put this antenna on, and you can see it changing. And it is resonant here. Now, we've got a lot of stuff. As I move my hand around it, you can kind of see it's changing pretty radically. But I'm going to put this generally out and away, and I'm going to drop a marker down. So this antenna is resonating right now around 886 megahertz. My goal was 910. I missed the mark. But I'm not calibrated yet, so this is just an approximate measurement. So what we're going to do is now calibrate this unit by going to the Cal button. And I'm going to say I want to go to the Calibrate menu, so this button right here. And I'm going to do an S11 one-port cal. So this is going to be a little bit shorter. Oh, for doing a one-port. So they want an open. Well, this is an open connector, but if we were doing very precision things, I'm going to put this open connector. You can see through it there. There you go. There we go. We can see through it. So this is an open that will maintain my impedance, and I'm going to get, where did my little, I hope it didn't roll away. Oh, there it is. They give you in the Cal kit this little mini vial that has inside of it the center pin for an end connector on a piece of plastic. This now simulates an open connector at type N. This particular Cal kit is calibrated for up to 18 gigahertz. Now at 1 gigahertz at 900 megs or a gigahertz, there's really not a lot of difference between an open with this and without this. But there is a little bit, when you get up to 18 gigahertz, you've got a lot of variability. You need this precise kit. So I often skip this open, and I just do it with the connector sitting unterminated. So I'm putting my little center pin back in the vial, and we'll put this away. Now the instrument says I want you to set it a short. So here's a short connector. It's a type N that'll fit in here, and it's just shorted from center to shield. and we'll put it on here and hit the short button. So now it's done that. Now, one thing that I started to do was when I was doing this, I was trying to get an angle. I was twisting this rear connector. You don't want to do that in reality. It's always best if you're trying to be nice to your 18 gigahertz cal kit to turn the, I guess, ferrule, is that what they call this? Not this piece, because there's female pins, tines in here to a male center pin that you're putting one into the other. If this is slightly off and you turn the rear, what you end up doing is splaying this connector out, and it doesn't make a good connection. And if you just paid $1,000 for this precision cal kit, you don't want to do that. So we've done that one. Now I'm going to go to the load, and you can see it as there we go. As I'm tightening it down. So I've put a 50 ohm load on this, and now the instrument knows, and I'm gonna pop off camera for just a second and leave you there, and I'm gonna grab, Mark has a really nice equivalent that I'm just gonna contrast and compare. And if we can go to the wide angle view, what is that, camera one? This is what some people call an OLS, and it stands for open, load, or open, short, load, OSL. This has all three things in one nice mechanical package, and I usually leave a end barrel on here, such that this is, you know, on the used market, this is probably $500, and this other is probably $1,000. You know, it's just getting your good equipment. So we've done these three. We're going to say we're done with a one-port calibration, and it's calculating its coefficients. So now you notice this yellow line is right on top of the red line, and we are now calibrated. So we're calibrated to this point on the end of the connector. So any loss in the cable, any impedance changes have been calibrated out, because we said this is a precision dummy load here, a precision short. How precise is a short, but it is, and a load. And so here is my quarter wave ground plane. The first measurements. But we're not getting the view that we want. Thank you. Perfect view. So we are looking, and what I've told this thing is do S11. And what you'll notice, Mark, if you can pan down just to, there we go. You see here it's saying this is illuminated, and over here it's not. So what we're doing is we're transmitting out and we're receiving back. And if I say measure instead, and I'm going to push the button up here marked S22, you notice these lights changed. So now the instrument is looking at the not red cable, the blue only, and it's sitting here totally open. And if we, there we go, I just putting my dummy load on, taking my dummy load off. So with this instrument, I can, at the push of a button, change what I'm looking at, and we'll see how that's useful later. That's the one thing that the Nano VNA doesn't have. So we're going to go back up to our measure. We're going to go back to S11. And you notice we're from the middle of the screen down to here. So out of this whole thing, we're using two vertical divisions, but I have 10 on my screen. Very wasteful. So what I'm going to do is I'm going to say a scale reference my position is the top of my screen. And I obviously didn't, because I'm off at an angle. Okay, so now we've moved up. Why would we want this red line in the middle? Because we're going to be looking at gain and loss. In the case of an antenna, I'm only looking at loss. So I like to bring myself all the way to the top of the screen because then I can see it. The other thing we can do is scale per division. We're sitting at 10 dB per division. Now, I like to stay at 10 dB log, as we quite often call it, because that's how my brain thinks. But if I'm really optimizing this thing, I could say 5 dB, and now we're using a good part of the screen. As you can see it here, and as I put my hand around it, yeah, that's a perfect view, guys, that dual screen. I think these guys are, what do you guys think online? Is the technical crew getting it here? I think this is, and maybe later we can do a view of the setup here behind the green screen, but it is complicated, and they've done a fabulous job with it. So now I'm looking at my little dipole, or my little quarter wave here, and it's resonating very low in frequency. One of the things you know from your theory classes is, how do you match this to 50 ohms? Well, you can play with your radials. We're resonating at right now, I'm playing Statue of Liberty here. Okay, that's fine. Marker. We're low in frequency, aren't we? Oh no, we've moved up with playing with those radials. We're at around 900 some megahertz. I'm just going to take my diagonal cutters and go. So this is return loss. What I want is the lowest reading here. And I think everybody on the call knows return loss, but if there's somebody that's new to that, return loss, and Bob defines that in his talk. So I'm assuming you've all been to Bob's talk already as kind of the prerequisites. And yes, this will be on the test at the end. So return loss, there we go. Return loss is a measurement of, in decibels, how much power am I putting out versus how much is reflecting back. If I take this antenna off and put a short out here, here's my short, the return loss, and why is it down there? Oh, I must have messed something up on here, but we're going to go through and pull up a different calibration later, but it's basically saying 0.03 dB because we calibrated out to here. So that's a 0 return loss. That says if I was transmitting 100 watts out, I'm getting 100 watts back. In VSWR, that's 1.0 to 1. That's bad. That's like your transmitter's going to blow up. That's a dead short. If I have a 10 dB return loss, that says 100 watts is going out, 10 watts is coming back. Return loss is what a bird watt meter does. You put your bird in line. Time for another beer. Or fuzzy water, sparkling water. Watermelon. If we're using, I just got tickled, excuse me. 100 watts out, 10 watts reflected. That's our bird watt meter. You put the slug in one way, read 100 watt. Turn it the other way, you read 10 watts. You might be lucky enough to, and there's no SWR chart on the bird. Instead, you got to sit there and do the formula with square roots and 1 pluses and 1 minuses, and unless you're Willem, who has a degree in applied mathematics, your head probably explodes if you're like me. So, but I can read a bird 100 watts, 10 watts, and say, that's 10 dB, that's a 10 dB return loss. There's certain ones that I keep in my head, but 10 dB is bare minimum, and that's about 2 to 1 on BSWR. 15 dB is a commercial standard for two-way radios, and 15 dB is about 1.5 to 1. And when you get to 20 dB, you're getting down closer to 1.2 to 1. And when you get to 30 dB, you're at about 1.05 to 1. Anything beyond 20 to 30 dB, your test equipment is probably going to have trouble measuring. So we really don't need this whole range for this. We'll see where we need the whole range for other things in a moment. So this is a one-port calculation. If we go to the wide-angle view from Mark here, this instrument down here is a portable version, and you can do the same thing. You can pick one of the ports and hook up to, we could do it placing this antenna on here, and we would get the same sweep. Where is this really valid versus that? And Dave, if you're if you still have the Mark trace that we had last night from field day, okay, yeah, we're going to go to that in a moment. So if we go back to, this is a good, where am I? I'm over here. So this is a piece of a, well, I don't want to call it a quad band antenna, a tri-band, 3-element tri-bander with a single 40-meter element. This is the actual 40-meter element that goes on the end of the driven element to turn it into a 40-meter rotatable dipole. And we had these at field day, and on this is a really nice little sticker that says, this is a TK, and it goes that way. Okay, so when you go to Cushcraft's documentation, they say, TK is a 40-meter trap. All the traps are labeled TAA, as in Tango Alpha, Tango Bravo, Tango Charlie, and when they go to 40 meters, they go to Tango Kilo. Well, so this trap, and that's a common thing. That's a good point, Mark. Thank you for bringing that up. I call this a 40-meter trap, but it's really a 20-meter trap because it's trapping 20 meters coming out this thing and letting 40 meters pass. So if we're saying trap means cutoff, it's a 20-meter trap that enables 40-meter operation. So on the tri-bander, there's one trap, I guess it's out here, and that's the 10-meter trap that allows 15 meters to pass. Then there's a 15-meter trap that terminates at 15 meters and allows 20 to pass. And then we have this 20-meter trap that stops 20 meters right here and lets 40 meters go by when we're on there. So we hooked all these up with the documentation. We looked at the labels, made sure the arrow is in the correct direction. That is significant because this is actually an LC, inductive and capacitive tuned circuit. You get it in backwards, it don't resonate the same way. It really needs to go. And giving you some history on this story, I don't know if you can read on here. It says TK, and maybe you can read that. That's somebody scribbled NG. It probably should say NFG. No good. This was unit number 1, and we actually did some measurements inside, 6 3/8 inches. We set this whole thing up, and it would not resonate. So, what do? You take it apart. And this is the inside piece. There's a metal bushing over it. And we said, okay, these are identical units. Where am I? I'm over here. These are identical units. And one goes on one side of the 40-meter dipole element, the other goes on the other. If they're identical units, shouldn't they be identical lengths? We kind of found out why our antenna wouldn't work. But unfortunately, we found out at the field day site. So it's coming up on 9:30. Why don't we take, how much do you want? 5 minutes, 10 minutes? 10 minutes. So let's come back at 9:40, and I will tell you the rest of the story. So
Before you go,
take a
John,
natural break, and yes, Willem, go ahead.
Can you zoom in on that, the big analyzer again? Just below the screen next to the port, just bend down a little bit, to the left. Just go left a little bit. That's
This?
the biggest USB port I've ever seen in my life.
That is a USB 0.1. Yes. In this old instrument, and those of you that need a break, this is just some trivia, so feel free to wander away. I won't be insulted if I see you leave. But this instrument, you could put a 3.5-inch floppy, or it had a protocol out the back that used to be called HPIB. Now I think it's GPIB is the generic trade name. But Hewlett-Packard interface bus. Oh, okay. Hey, Willem, what do you want to put on here? Yep, it still works. Yeah, what's a floppy, as Dave says. Yeah, Mark actually still had one. But what you could do is you could save some of your traces, you could save your setups, and you'd put it on a floppy such that when you come back, you'd be set. But and when we come back in 10 minutes or so, I've preset this instrument and pre-aligned it, and we'll be doing exactly that, but I've just stored it in internal memory. So we'll see you in 10. Okay. We're back. And there we go. That's kind of interesting. I grabbed a bottle of sparkling water from one of our sponsors, but we jokingly call it our sponsor. But it's green, so it's green screening, but liquid death. The sparkling water of RF engineers. So, okay, so we're back. I see we still have, 20-some people online? Thanks for being here. Again, for those just tuning in, this was supposed to be on 3D printing, but James Isaac had a family emergency, so he ended up with me. So we were talking before the break about tri-banders and how can we do useful things with our fancy test equipment. And we really put this to the test at Field Day when we bought a brand new tri-bander, and I think Dave had a a photo that he researched during the break, and that we're going to see if we can display on here. But they have, the basic tri-bander has two traps on the main, on all three elements, and then these final traps for 40 meters or 20 meters that enables the 40-meter operation. So we had two old tri-banders that we brought to field day. They're all Cushcraft A3S, and all of our antennas are that. And then we bought a new one, brand new A3S, still in the box, brought it up to field day, so that was our third. And then we had three 40-meter kits, one that was purchased a couple years ago, and two new ones purchased, of which we're looking at some of the 40-meter kits. We have still yet to get these working. So we get up there to field day, and we put the new tri-bander together, and it just wouldn't work. And even as a tri-bander. So Dave, do we have the okay, well, there's a picture of the Cushcraft A3S. This, you notice it says MFJ. Cushcraft is now owned, the Cushcraft brand is owned by MFJ. They also own High Gain, so the High Gain antenna series, the High Gain rotators. You know, Ameritron is part of MFJ. They have a lot of brands all under their one brand name. So if we go to the spectrum analyzer, if they can bring that up, view of the tri-bander, very useful tool of whether it's this network analyzer or this smaller, there we go. There's one of the pictures. So what we did is we created a calibration and a sweep for this unit that went from, I'm looking for it on the bottom. Okay, 5 megahertz on the bottom, the start frequency of 5 megahertz, and this is in the upper left of your screen. 30 megahertz is the stop. We ran it through, it says here cal status is off. Don't know, next time we should figure out why the cal is off. But because we changed the frequency? Okay. And we're going to kind of talk about that on the Hewlett-Packard of what we can do. But this shows the furthest left marker is the return loss in dB of the 40-meter element. Then the second marker to the right, M2, is the 20-meter, M3 is the 15-meter, and M4 is the 10-meter resonance. So this unit is taking the transmitter, very low power, going from 5 megahertz to 30, just going up the band and repeat. Lather, rinse, repeat, just like it says on your shampoo bottle. We said earlier, this is in dB, this is return loss. Is anybody on this call happy with where's marker 1? 9.94 dB of return loss. What did I say about a 10 dB return loss? Crap. So these 40-meter kits would not resonate. I look at 20 meters and we're down in the 28 dB, 27 dB, somewhere in there. Or no, 24 and a half. Yeah, so it's looking pretty good. 27.42, there it is on the screen. 15 meters, 16.43, okay. We're 1.5 to 1. 10 meters, where is it there? 24. So those are acceptable, but the 40-meter operation just doesn't resonate anywhere that we want it. So we spent a lot of time, and one of the, I think, newer features of Field Day And we can go back to the, maybe camera one, Dave, please. One of the newer things in field day that I remember from only the last couple of years is they had this thing called the teaching bonus points, where if you actually did active teaching, you could get some points. I don't remember whether it's 100 points or 50 points or 1,000 points, but we were up there and we were doing this. We had, I know, at least four electrical engineers and hams, and we each put at least 8 hours of work into these tri-banders. So over 30 ham hours to try to make these tri-banders work. When we were all said and done, we were able to get one tri-bander working with the 40-meter kit. So it had tri-bander, 3 elements plus a dipole. The other we couldn't get working. After 30 some hours and tens of thousands of dollars worth of test equipment, couldn't make it work. We also had one of our, who I describe as really smart people, Willem, on the call, our director of continuing education. He was battling a multi-band vertical, also made by Cushcraft. I think it was called an R9. And it would not resonate on certain bands. But again, we were using this instrument to sweep from one end to the other, looking for the resonance points. And a long story short, we were doing the equivalent of that sweep here. But the long story short is what we learned is this sticker that says this way up or this way down was on backwards. When we took the trap and ignored the sticker, it resonated. I forget whether it was on 17 meters or 20 meters or 15 meters, but so we spent a lot of time. Our ARRL official and observer said, you're supposed to do training on something like that hams would not be expected to know to get these bonus points. And I said, well, you mean what we're doing doesn't qualify? And she said, no, every ham should know what you're doing. Well, if we had 4 very seasoned hams spending 8 hours apiece, I think this is a little bit beyond everyday engineering, and I think it should qualify as the bonus points. And we kind of were arguing it a little bit, and I looked at Willem and I said, is this a college level course material? And he said, no, it's graduate level. We got the bonus points when we were done. But we're literally reverse engineering LC circuits. Without this equipment, we wouldn't have stood a chance. If I had had a rig with a watt meter, we'd still be looking, because we're looking at a problem this big through a cocktail straw. You can't see what's going on around you. With this equipment, you can. And I know Willem is probably back from his break and online. Do you want to comment at all about what we were doing? Because you were there, and you and I had some really good, what I call arguments. They were technical arguments where it was more like thesis defense of what was wrong in these things. But Willem, do you want to say anything?
I mean, what it comes down to is sort of what Ben Matthews' talk about troubleshooting was, right? You are trusting that the factory manufacturer is doing this correct. And obviously, just comparing the two traps, there's something not right here. But then what it came down to is, they probably hired somebody at $5 an hour or $10 an hour, whatever the Mississippi minimum wage is, to stick the stickers on the traps. And that day, that person was either not well trained or just a little off. So what is the probability that they put that sticker on backwards? And that's what it turned out to be, right? It's like they say, why is something always in the last place that you look?
Yeah.
Because once you find it, you stop looking.
Exactly. And you look at these things and I say, okay, they're similar to here, similar up to this point, the same. One of these things is not like the other. And we had 4 of these that were 3 different lengths. So we said, 2 are the same. Let's try those 2 on the antenna. Didn't work. So apparently we have 2 that are wrong, that are alike, another that's different and wrong, and only 1 that's correct. So, but one thing that's just occurring to me is we do know, Willem, we do have 1 kit that works. We just haven't taken it apart yet. And we were hesitant to do that because we had 1 that worked at field day. We didn't want to have none that worked. But that's probably what we should go back to, because you've got to take these little plastic cups off and get this metal aluminum tube out and not crack this white plastic that's in here that's pretty delicate, and not break apart this. They literally just took enameled wire and then kind of connected it in here. It's a terrible design. But yeah, I think Bubba down there in Mississippi was doing a little bit of heavy drinking before he put this antenna together for us. So, and similarly on that trap vertical, it just didn't work out. So we eventually got it working, but so that's kind of one practical. You could take your UHF antenna, and there we go. There's better contrast, and tune it. You can do your HF antennas, your Yagis, your dipole. I don't know if anybody on here has one of these Rig Experts, or is Rig Expert that's the old AEA model, isn't it? You may see MFJ has one that has a name, but there's various little box with a meter on it, and it's basically a poor man's nano VNA, except they charge more money for it than a nano VNA because they've marketed it as a Rig Expert. This is what you need to do your antenna. But if you have a nano VNA, you take the little box. I was using my iPhone as a prop since we don't have one. You take your iPhone, you put the nano VNA, set it for a 1 port, and put it into your HF rig. Yeah. I don't know what low frequency on a nano is.
But the one thing, and you kind of alluded to it though, is...
Are you on mic?
I'm on mic.
Okay.
Is, you know, I've
swept
antennas and stuff using a network analyzer, and it's almost, you need 2 people to do it. It is nice going to the field or doing portable to, you know, it's a little slower on the sweeps, but in order, you know, it's a lot easier in the field, and
yes.
I'd hate to take a $50,000 piece of a test equipment or
yeah.
whatever it is today and throw it in the back and take it up to some of the sites that we go to.
Yeah, this is just too big for practical field work. I'll use it at a repeater site, but I'm not going to use it at the back of a van, as Mark points out. In a field, I'm going to use one of these smaller and even battery-powered instruments that's very easy to hook. Where's the camera? Very easy to hook in and to operate. So we will be continuing that, and I noticed one of the guys on the call, Glenn, is on here. He was very helpful, as well as Dave and Mark, who's here in the room with us. And then Tristan came in one day. I'm trying to remember everybody. We were camped at my house for probably 3 days of many part of the afternoon, maybe even it was even 4, taking these apart, cleaning them, trying to reverse engineer and figure out what was going on. But one way that you can do that with your network analyzers. So I'm getting ready to go on to our next area, but why don't we see if we want to open up the bridge, and if there's anybody that wants to ask a question or comment. As I said earlier, this was last minute. This was the best I could throw together on 24 hours notice. So it's highly interactive and participation. Does anybody have anything? Either unmute or send it in the comments and they'll read it off.
So is there a way that you could actually put that trap together? Because the actual cover is part of the capacitive part of the system,
Yes.
right?
Yes.
How would you load that up and actually see the absorption of that trap?
A lot of trial and error and putting it together and taking it apart, or a test fixture that I don't have. So what I tried to do was sweep these traps as at home I have boxes and boxes of these traps from all of our defective antennas, and I take the clamp, the things off so it's just a trap. And then what I did is, Mark did the same thing. Mark, do you want to get your little coupling? So how do you measure this? This is a great question, Willem. So I went back to my early days as a ham, and I remember my old, they were made by Heathkit, and they were made by ICO grid dip meters. And I found one on eBay in mint shape for like $30 with all of the coupling coils. So I actually ordered and bought one. And what I was trying to do was go into this with the coupler without this lower piece on here. We'll make this a little easier to do and simplify the display. I have a few basic tools here on the bench. Okay. So this is the basic trap from Cushcraft. These are drain holes on the bottom. So if you're, little pro tip here from Home Depot, if you're going to put this up in the field, don't put these up, put the drain holes down. And usually they put the sticker on the top so that you can do that. But what I did is I tried coupling into this with my grid dip meter. And Mark built one out of a little connector, and this is just 3 turns of number 14 solid copper wire to make a coil. He tried it coupled through the base, which really isn't, I think, as effective as parallel coupling on this. So you can see, am I on which? Okay, there you go. So we can either try to couple through this way. Really, the maximum field is not in this coil. We get better coupling this way, but I couldn't quite get resonance of this trap, not knowing out of circuit without the other pieces around it where it was resonating. But what I was doing was looking for a resonance point where it's a grid dip meter. I'm dipping, I'm getting a resonant circuit, so it's sucking the energy at that frequency. And I said, can I tell the difference between one that's designed to stop 10 meters, stop 15 meters, stop 20 meters. We just couldn't quite get there. And once, as Willem points out, once you remove the outer piece of aluminum, it's just a lightweight piece of aluminum tubing. And they put some little dimples into these plastic rings, and there's another plastic ring that's not on here that you can't see. That's the capacitance. The capacitor is electrically connected at one end and not at the other to provide capacitance, and then inductance in this piece of enamel wire. So when you take it apart, you can't debug it unless you're the designer and know what you were doing and know the inductance and capacitance of all the materials. So you're kind of going blind, or maybe with the network analyzer, you got the one-eyed leading the blind.
You know, and I think one of the other things that even on the tri-band traps, when we went through them, there was a lot of different things. I think we looked at some YouTube videos and some things that once we had these apart, you know, some of them are potted metal, some of the sheet metal screws were there. We found some that the aluminum or the enamel wasn't off of the wires. So we've opted to do some rivets of like metal on some of them, on the ones that we rebuilt.
We rebuilt, sometimes they just have a sheet metal screw here without any lock or stars, and they would get loose, and you could just, I don't know, I was going to say it's a bad design. It's not a good design. It's not a longevity design. And one of the other things that these little, if you have one, these little caps weather poorly, and eventually, if I can get it off of here, but if you do it right, you can get these caps off, and I'm not going to be able to do it here live. Oh, there we go. These little things are weak, brittle. They get, when they get old, they crack, and where am I at? Over here. You can see the plastic in here, and there's similar. This is the end that is not electrically connected. But James Sizek, who was supposed to be our speaker today, said, oh, look on Amazon, and you can find some boat and RV heat shrink with the glue on the inside, and we simply cut some pieces of heat shrink, and then we shrink it down, and if you make sure the drain holes are on the bottom, they'll drain. You won't get water in your trap. You can still get some small bugs, and that will clog them up, and if they get wet, they are kind of conductive. But just another pro tip. I think Dave may have some comment.
Yeah, I was going to ask you to summarize what we did to the 20-year-old traps to refurbish them.
First, the heat shrink, and then Dave noticed that these, which, can we maybe go to camera 2? Okay. These sheet metal screws, although I would call them something different. There's one of the sheet metals, and there's one. I would more call them a 4-letter word that begins with S, ends in T, and means excrement. So these are a scat metal screw. They're loose, there's poor contact. They tried to tin these with solder, I believe. But we cleaned these up. Instead of a sheet metal, we would use a pop rivet, aluminum pop rivet, because this is aluminum on aluminum. We're still experimenting, and ironically, Dave, those traps don't work either. So
I think you should talk, I thought it was pretty unique, the plumber tools and the modification for cleaning oxidation off of those traps to keep from having to do it all manual.
That's a great comment, Mark. Thank you. So you've probably gone to Home Depot and you can buy, and I guess our web team or our web browser could bring them up, but I'm sure you've seen them. It's a little plastic block with wire brush on the inside, and they're in your plumbing department, and you can put your piece of plumbing tubing and then scrub and really get this nice. You can also just use a piece of emery. Keep in mind, aluminum nearly instantly oxidizes in oxygen after scrubbing it. So it's all a matter of how good of a connection, I guess I'm over here, how good of a connection can you get? But they also make some of these little wire brushes to get the inside, because whenever you're putting a piece of tubing on, you're cleaning the outside, you also got to clean the inside. So they have some little wire brushes, and I simply chopped them off with my hacksaw, chucked it up in my hand drill, and we would run that little wire brush on the inside of this, cleaning it all out, and then we'd kind of like, and you'd see the residual material, and then we'd put the element in and clamp it down. We'd get rid of their steel hose clamps, and we invested at Home Depot in all stainless hose clamps. And I drove Mark and Dave crazy because, there it is. So the HDX 19 in stock, okay, here in Firestone. Does it say what the cost is? I think this thing is like probably $5. Now it's inflation, I'll guess 10. $11.28, okay. And they also make some that are just that end piece of wire brush with a little like screwdriver handle, and those are the ones that I cut off to put into the drill. Thank you, Dave. So the jury's out on, do you use NOx or not on the aluminum to aluminum? And boy, I just don't know. But what we've been thinking about and toying with is, I have a MIG welder for steel, and I also have the aluminum stinger. And what we were debating is, once we get this thing to the right lengths, do we go in and, let's see, I'm on this camera, okay. Do we go in and when we put the other piece of tubing in and hose clamp it down and verify it's resonant, do I go in here and just put a little spot weld or just a little dot? Because I don't want to burn through the material, but I want a really solid electrical connection. I'm kind of betting that I could do a little tick, 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 tick on the side of this, just a little bubble, little tic-tac of aluminum weld. And hopefully this thing will last longer than this material will corrode. Similarly, do we also just put a little spot weld, aluminum weld in here? I don't know. We're working on it. We're putting far too much effort into a Cushcraft antenna, and I'm honestly debating finding a different brand. Cushcraft, some people say MFJ stands for Mighty Fine Junk. And they have some good products, they have some not so good products. They have lost quality control on their current antenna products. I hope they'll bring it back, because this is a reasonable, reputable, low-cost tri-bander that you could use. Same thing with their monobanders. But if they don't get the dimensions right, you don't get the connections correct, it's a dummy load up in the air. So,
Well, but I mean, your observation was exactly it, right? We're all hams, we're all cheap. And, you know, if they can sell that antenna for $10 less, that's what we want. So they tend to cut a few corners in order to save a buck here or there. So, you know, we sort of deserve it.
we kind of got what we deserved, huh? So
Just the other observation about putting no aux on it. I don't remember exactly what the name of that product. He said I have to go downstairs to go and find my bottle of it. But there's it's something like no-ox, but it actually has little copper flakes in it that's supposed to give a better conductance. And I've had really good luck with that on antennas that I put up for a long time that, basically are next to impossible to get apart if they've been up in the air for a long time. And that
Okay.
material made it a lot easier to take things apart after they've been up there for a long time.
Now, the next question would be, you said it's a paste with copper in it, flakes of copper. And our antennas tend to be made of aluminum. And copper and aluminum will provide copper oxide rectification and galvanic action. And it may actually make our antennas noisier and poorer connections. I don't know. But that would be something to look at the bottle and really verify. This can be used on aluminum.
Yeah, I don't remember the name of the product, but I mean, it's sort of a copperish color. And I think it is specifically for aluminum antennas, but it has some kind of a metal powder in it that the manufacturer claims is better for conductance.
As long as it's for metal, and this might be something that we want to ask Tristan, is his other half, Adira. She is a PhD candidate in metallurgy, and I'll bet you has a lot of knowledge, as she's an MIT grad and now over at School of Mines working on her PhD in this field. So, yeah, we should try to get a few answers on that.
An eclipse, some people may want to go out.
Oh, is this the eclipse?
So it's in a couple.
So
I know the peak's at 1026 is supposed to be the peak for the Denver area.
Well,
So
let's finish talking about this a little bit. And what I'm going to do is, in my brain, I'm kind of going through with my producer here and my technical director, is I'm going to get ready to start to do some filters and how we can use this. I intentionally said this was a talk on 3D printing. This wasn't a talk on UHF filters. So how do we make this interesting to a majority of people? I said, let me try to get this into the HF world, into something that people would have, and I hope this has been interesting to you. I wanted to get some of the HF filters that we use at Field Day to keep one station out of another, knowing we also just did with some of our partner clubs in the area, peak-to-peak HF event, and we did have some issue with at the site that Jim Dixon and I were at, and thanks for that input on the Eclipse, Jim. We did have some crossband interference, but I couldn't get those. I don't have them, and I couldn't get them in 24 hours. But so what we're going to start to do is move our way towards the Eclipse. I think maybe Mark can check out what our status is here while we're doing this. What is this, Mark? Oh. Ask and ye shall receive. 14 megahertz, 200 watts, and he's got the sweep data, but you're not going to show me that. Mark, I can't work with that. It's got UHF connectors. Or as I call, why do we call the PL59, the SO239, a UHF connector when it's not rated at UHF? It's more of an HF connector. But, so I guess if somebody can keep an eye on the Eclipse, if there's something to see, we'll take a very brief break. I forgot my Eclipse glasses, so it's not like I can look at it.
These are inventoried.
Do you want me to give them back to you in serial number order? he's giving me a couple of adapters from HF to Type N. And they're silver. That looks like real Teflon. Okay, these are good ones. Yeah. When you get these at a ham fest, which camera am I on? There, I never, they don't have tally lights on the camera, so I never know what I'm looking at. And my view monitor is off to the side, and I have to look. But these are nice, silver plated. When you look in, sometimes at a ham fest, the material is Teflon, which these appear to be, and appear to be silver plated. There is a white material that I call TIP, T-I-P, and that's Teflon impersonating plastic. And that stuff is scat. It's lossy, it's cheap. So if you look at it and the Teflon doesn't look quite right, find yourself another connector, because it's probably not very good. Mark, if we could go to the view here, what I'm going to do, let me get rid of the liquid depth, is I'm going to hit the preset button. I'm just going to start over, because just like Julia Child on her cooking shows, I set this up for tuning UHF duplexer units, and I've got it pre-saved, including the calibration. So we're going to run uncalibrated. I'm going to start at 1 megahertz, and I'm going to stop at 30 megahertz. I'm not going to have a nice division here. I should have done like 10 to 30, then the vertical, but we don't care that much. I'm going to move my position up to the top, and I'm going to measure through this instrument, and so I'm going to hook this in, and I don't know, Mark, we might want to go to a little wider view so they can see what we're doing. So, okay, there we go. So I'm hooking the port 1 to the left side and port 2 to the right side. So I'm going to call this port 1 and port 2 as well. And look at that. You can see. So what we're doing is I'm going to say measure S21. So how much am I getting over here from over here? And we have this kind of unique shape. And this is a really good example. And okay, 1019 for, I'll let one of you guys go figure out if we need to look at the eclipse. So I'm going to put my marker on, and I'm going to run it down and go right about in the middle. And where is my marker? 13.9. What does this filter say? 14 megahertz. I like the way they etched it and engraved it in here. And I'm told somebody like James Sizek, that was going to talk about 3D printing, and Jim Dixon, who's on the call here, has some skills in this. I don't know, Jim, can you burn all the way through an aluminum box, or do you only mark on the surface here?
You can only mark to cut aluminum, even like something as small as a 1/16 of an inch thick.
Okay.
You need at least a 400 watt
Okay.
fiber laser. CO2 lasers and diode lasers won't cut through aluminum.
Okay.
Okay.
So
Let's take a quick break. It looks like it's started. It's not full yet for those that want to do it. You want to come back in what, 10 minutes?
oh, this is
Eclipse for the people want to.
okay. Tell you what, we're gonna stick. It says they're out looking at the eclipse, and but.
If anybody that's not watching the clip has some questions.
Yeah, Mark, what are you on, Mike?
My mark is down.
Oh, his mic is down. Mark Skelton says if you are not watching the eclipse and you have any questions, we can start to kind of go through. But so feel free to unmute and talk to us. Or if you're enjoying this, feel free to tell us, yes, I'm enjoying it. If you're not, please fill out a complaint form. They are readily available, and all you need to do is, I have one of the complaint forms right here. Just grab a $100 bill. There's a space on the back for you to write your complaint. Please send them in. And I promise we will read every complaint form. If you wish to submit multiple complaints, please use a separate form for each complaint. And we're happy to take them. So, and all complaint forms will go to benefit Rocky Mountain Ham Radio. So,
I thought it was on the Rocky Mountain Ham app.
maybe it could be on the app. And, yeah, but all you have to do is, if you're using the form, we love complaints. We love complaints if you're using the official form. So, okay, well, it's 10:30. We're going to start to move through this filter. Mark, do you have the manufacturer's specifications? Because I have a feeling. And the model, and so this is filters for ham radio. Bandpass filter, PBF200. It says it's 14 megahertz, 20 meters, 200 watts, ICAS. And we all know what ICAS means. That means don't key down for long periods on FT8. Intermittent commercial, I guess that's what, intermittent commercial and amateur service. So, oh, here it is, 50% duty cycle. And, oh, this is made in the Russian Federation. Volgodonsk, Russia. Can't pronounce it. So they provided a nice little chart. You don't have to move it, Mark. And, but we are a little off the analyzer up here. So this is a 20-meter filter. What kind of filter is it? Well, it, to me, looks a little bit like a bandpass filter. Get my pointer. Because we have a brief peak over here, then we've got a nice flat top and another over there. So I'm going to take my markers, put my first marker on 14.1 megahertz, or maybe what I'm going to do is marker one 14.0 megahertz. Why is it not seeming? Because I have a really broad span. I'm going to put my second marker at 14.3 megahertz. So you can see the 20-meter ham band, pretty narrow, right in, pretty narrow on the span, because I'm going from 1 megahertz to 30 megahertz. But, so it's the entire ham band. We're not running calibrated, so I can very easily say center 14 megahertz, span 5 megahertz, and now you can see the filter comes up. It's really nice and flat. I'm looking in here so I can say, well, does it distort my signal, and what's the SWR looking through this, or the return loss? We're at a minimum of 20 to 30 dB down across the ham band. This is a pretty nice filter. I could say, well, this is looking from port 1 into the other way, but I can turn myself around, and this should look very similar, except for different tune elements are at one end versus the other. Very nice filter. And there's the sweep, looking one direction, looking the other direction. And we would expect the sweep to look very, very similar on this kind of device. Now, if I'm using what we call an isolator, we'll get into later, that's going to be very different. So But you could test this with your Nano VNA by putting one port to the other port, do an S21, and this is very good. Now what I'm going to do is span out to 50 megahertz, and I'm going to grab a marker. I'm going to use marker 4. And so there's a lot of rejection on marker 4 at 21.4 megahertz. So if you're running this at field day, you're going to get a lot of 20 meter to 15 meter isolation. And as I bring this up to 28 megahertz, again, a lot of isolation, because where is, let me do, how about I'll do center 25 megahertz, span 50 megahertz. So here's our 10 meter, 50 megahertz marker. Here's the ham band. If you're on 20 meters, calling CQ, and you're at field day and you're on all the bands, which operator is going to not like you the most? The 10 meter operator. Second harmonic of 14 megahertz, we're down 90 some dB. That's a nice filter. And when we go to the paper that they provided with this, it's about the same shape. He's showing what he calls attenuation, and he shows in here on his instrument, he gets VSWR and return loss at the same time here, I guess. Mark, are these still available?
I believe so. I got those from DX Engineering.
DX Engineering, do you know roughly the price class of this? Is this a $50, $100,
I was
$200?
thinking 2 for the lower power. I don't recall right off.
So roughly $200 might be a good thing for your club to invest in if you're looking for that. As we go through these markers, there's also a nice notch at 15 meters. And there's another one up here at 7 megahertz. The Russians did a nice job on this. And I know John Maxwell I don't know if he's still on the road with us. He was traveling today for business. But he ordered some of these. Where'd Mark go? Marky Mark. Oh.
We're doing Google search.
Oh, okay. But he ordered some from a different brand, and so we have them at field day. And Dean Mertz, who I don't think is on the call today, he has some of these that we use at field day. Very handy little things. So kind of tells me a little bit about when you're at field day, and we did this we had a special event for the Peak to Peak Highway. On this call today, I think only Mark, myself, and Jim Dixon was up there, but if I don't know if Mike Ring or Joe Hawley's on the call, but or on the session today, but they had an FT8 station that was about 50 feet away from one of our QRV vans with the tri-bander. And apparently the FT8 station running about 15, 20 watts didn't bother us at all, but our 100 watt sideband station annihilated FT8. So the way we've gotten around that is we move our field day antennas 500 to 600 feet apart, ideally. And being that we're running out of vans and we can drive the van over as long as we stay within the rules of I think is it a 1,000-foot diameter or a 500-foot radius? For the field day site, we're okay, so that's what we do. If you're going to try to run 2 stations close by, you're going to want to get yourself some of these filters. So, and while we were in eclipse mode, and it's looking a little darker out there. I'm just looking out the window here at Mark's house. As we were, I was looking at the window. I think I saw it said Jerry. I'm assuming that's Jerry Villauer. Someone on the call with us said he's got a Mosley, not a classic 33, but I want to say he said a TA 33. As a kid, my dad bought, and I was, in junior high school, so I guess we had a Mosley Classic 33. The difference in that tri-bander is it has one trap assembly on each side of the element that works at 20, 15, and 10. And those are excellent tri-banders. I really love the feed mechanism on those. It's very weatherproof, very reliable, and if that was Jerry W0GV, he said worked beautifully. He's had it for decades. That might be a good antenna if you can find a Mosley TA33 or the Classic 33, or even the 36, the 6-element version. It's a lot of elements on a very short boom, so you're not going to totally, it's not like you're going from 3 to 6, you're getting a lot of gain. You do get a little bit more, but it's not quite as much as you might expect. But excellent antenna, and maybe that's what we have to start doing in Rocky Mountain Ham. So, okay, what I'm going to do, unless there's questions, and if there are, break in. Otherwise, I'm going to start moving us at 10:41 into some VHF. And what I'm going to do is the example, I just bought this duplexer at the Ham Fest. Will it work? And then I think I'm going to go to, I picked up one of these cheap crap duplexers from China. Will it work? And I think you'll find that's an interesting answer. So, Mark, if we could, or Dave as our technical director, I'm going to focus in on the instrument here. There we go. Mark, if you can pan out just a little bit to get the entire instrument. Okay. So what we're going to do is we're essentially going to go through a full 2-port calibration. So I'm going to calibrate port 1 and port 2, and I'm going to set this thing to look across the UHF band. And as opposed to doing all of that, just like, as I say, like on Julia Child, she pre-cooks her dish. So I've put this thing in the oven for 1 hour, and now we're going to pull it out of the oven. This morning, 14 October 2023 at 8 in the morning, I saved all my values in register 12. I'm just going to recall my state. Looky here. I'm going from 100 megahertz to a gigahertz. I have on the upper screen S21, so I'm looking through the unit. So I'll put a type in barrel in my cables here. So it's saying I have 0.11 dB of loss. That's essentially 0. We're just going to ignore that. And here on my bottom, my return loss is down at 37 dB. Remember earlier I said more than about 20 to 25? You're kidding yourself because you're starting to hit the edge of the measurement of the equipment. So this is the Hamfest duplexer. We're going to look at it from 100 megahertz to a gigahertz. And can we use this thing? That's not a good spacer. We'll just leave it the way it is. Can I use this thing, or maybe this? can give a little better view on my repeater. So, as I say, this is virtually the first time I've put this thing on. So I'm going to hook up, and if we can, I guess, okay, yep, to a little wider view here from Mark. Okay, there we go. So this particular duplexer is marked cell wave. It's got a catalog number. It's not going to mean anything to you because it's a lot of numbers. It says frequency untuned, and somebody scribbled out the un to make it tuned. And it says 435 to 470 megahertz. That's just the sticker on the top here. There's an antenna port here on our, there we go. There's an antenna port. There's a port marked either I, or it's really marked high, right here. And there's a port marked low, or ol, if you got it upside down. Low and high frequencies. So I'm going to take the output, or essentially the receiver on here, and put it on the common port. And Mark, if we can go up a little bit and capture, perfect. And if you even want to come in, you can, but. So I'm now connecting to the low side. And I'm having trouble getting my fingers in here. Do you remember that old television program of Geraldo Rivera and Al Capone's vault? Well, this is the first time we're going to tap into Al Capone's vault. What are we going to see in here? Oh, come on. There we go. And I've left the other side unterminated currently, but I'm going to put my precision termination. And you notice you see it changing a little bit. We'll see that later. Oh. Will this work on your repeater? I don't know. It says it's tuned. Not intuitively obvious to me, but this is a pretty wide span. And since we're trying to get some audience participation, Dave, you've got the guest list there. Was the Jerry that I saw, W0GV, on the call? Or is that the Jerry that I saw? Are you, Jerry V, are you on the call? If you can unmute.
Yeah, I'm here, Doug.
Okay. So if you don't mind being part of our presenters here, is this a good duplexer from what you're looking at so far?
Well, let's see.
It's pretty hard to tell, isn't it? But I'm going to grab a
yeah.
marker, and I'm going to put that marker at 450 megahertz. Ah! Maybe that's a clue. But I'm going to grab another marker, and I've also got a whole bunch of stuff up at, where's marker 2? 492. The bottom line is I was hoping you would go, I don't know, you're too wide on your span. You've got to zoom in a little bit. That's what you were going to say, right, Jerry?
Oh, absolutely.
Yeah. So what I'm
read
going
my
to do is I'm going to go to hit my Cal button up here, which you can't see, but you don't need to change, Mark. But I have the correction on, but I've turned interpolation is currently off. I'm going to turn that on. Now, what that's going to mean is the screen is going to be a little bit slower, but as soon as I change my start and stop frequencies, my calibration is, the instrument's saying, Doug, you calibrated me a particular way and you varied that. But what I'm going to do is by turning interpolation on, I can say I want to go from 440 megahertz to 470 megahertz. We're calculating the coefficients. It's going to take a little bit. Ah.
Hmm.
That's looking a little better, isn't it? And now I can go marker, marker 1. So this appears to be maybe 452 some megahertz. And, well, maybe not. So this is our pass, S21. So this is going in one port and coming out the other. And this below here is the VSWR, or the return loss. Where this filter has the least insertion loss is not the point that it has the best match. So if this is on my low, which in the ham world means our receiver, but in the commercial world means our transmitter, it's barely 2 to 1. But if I take my marker down, 451.284, so let's say 451.3, we've got a pretty good match here. And I'm there's a double hump here, isn't there? Which says some of these resonators are not tuned quite right, or some of these cables that you can't see in here. Maybe we should back off just a little bit, Mark, on our Zoom. He's sitting in his chair. He's not standing at his camera, slacker. So these tuning rods, which are down below here for the main frequency, the rejection, and these cables, when it's double humped like this, it says likely some of these cable lengths are not quite right. But it's very close, because that's a limited double hump. So probably it's just a matter of where it's tuned. But you might say, hey, I've got decent insertion loss up here at 453, but your transmitter's not going to like it. Now look what happens when I take this load off. Should get dirtier. Okay, it didn't. Doesn't always do that, but often it does. And so now what I'm doing is I'm going to swap these two. I'm going to look at the other side. So if this was a ham system, this would now be our transmitter, and this would be our receiver. And Mark, we might want to zoom in on the screen because this is very interesting. Marker. There's the only place that it's kind of decent. So I'm looking at this return loss. So we said this is the high frequency. So this is our transmitter. I wouldn't want to have this thing transmitting anywhere else but about, I would hope that if I'm going to use this filter the way it's tuned, that my repeater transmitter is on 458.15, essentially. So we're going to write that down. 458.150 megahertz is the high, or the TX. And didn't we say about 5 megahertz away, 453, 1 or 2, was our receiver? So this was obviously a commercial duplexer. It's got a lot of rejection. I can put another marker on here. So my first marker is on 458.154. So let me put my other one on 453.154 megahertz. So my transmitter got a little bit of insertion loss, 1.8 dB. It's a little high, but it's not terrible. We could do better by, at most, half a dB. and our receiver is down here, there's a lot of rejection from the transmitter to the receiver. But I wouldn't transmit in through it because it's basically a dead short. But that's kind of what you want. You want your transmitter to go through and the receive energy not to go through. Otherwise, you blow up your unit. And if I go to 50 megahertz, or maybe I'll go to 100 megahertz. Let me see what the picture shows. Yeah, I'm going to go a little further, 100 megahertz. Now it's going to calculate out the calibration components. But some people will often ask, and I'm going to put another marker. So let's say that we're running this as a commercial repeater, and we have a ham repeater, and I'm trying to well, we have sites like this, like Jerry's site, but I'll just use, how about I use 444.0, 449.0, because those are easy numbers. There's a ham repeater there along with this 453. So as I run my marker back, here, I'll just do it this way, 449 megahertz. How much isolation do I have from the commercial transmitter or this high frequency to the ham band to our transmitter? There's a bit of isolation there. That's 10, 20, 30, 40, 50, 70 dB. But as I go down to 444 megahertz, look what happened. I'm down to 10, 20, 30, 40, 45 dB. As we go further away, this waveform is coming up. This filter does a very good job at 5 megahertz from transmitter to receiver. It doesn't do a good job 10 megahertz away or 8 megahertz away or even further. You've probably seen some of these, and this is not a bongo drum. It's just a very large cavity. This happens to be for UHF, and it's currently tuned 464 megahertz. It has 2 spigots, so this thing produces a bell-shaped curve-like response. So this would be on this screen here, coming up and back down. So where this is going up, this other filter in series with this is going to bring this sweep back down. And that's what we end up doing in the field to deal with multiple repeaters at a site, but that's maybe something for a smaller tech talk for those that are interested, because I doubt a lot of people on this call have commercial and ham repeaters at the same site, and that's probably not why you tuned in here. But so this filter so far appears to be generally tuned for commercial service. It's not perfect, but yes, I think it would likely work on your ham repeater because it is a 5 megahertz from one frequency to the other designed. There are some of these that are designed for 5. There's some of these on UHF that are designed for 7. Some filters are designed for 9 megahertz, and there's others that are less common, many, many megahertz, but those are kind of rare.
I had a question, but you'd mentioned earlier.
Yeah, Mark.
Is my microphone on? That you mentioned earlier the critical lengths on some of the cables in between the cavities. Is there, I mean, do we know how far we could take this down, or when do you have to consider changing those lengths? Are there, you know, this is a
That's a great question.
We got dust, and we've got this to find out.
Yeah.
Can we go clear down to 443?
I'm not worried about dust, but what I am worried about is exactly what Mark said. These cables might have to change lengths, but how do I know?
Because sometimes
So-
you go to a ham fest and the cables may not be there,
Yeah.
or
So how do I know? What we're looking for Why did I do this way before I moved the filter? I want to make sure we have a properly designed and properly functioning filter before we modify it. When I used to work at Ericsson Lynchburg and we were designing radios, I can't tell you the number of times that somebody said, I just modified this and it doesn't work. Can you fix it for me? And I asked them, did it work before you modified it? And they say, I don't know. Then I can't fix it for you. I can only fix something that was working. If you didn't test it before you modified it, go see somebody else. So we've tested this before we modified it. We're not seeing really off frequency, really bad signals. I'm not seeing bad insertion loss. I'm not seeing really, if I see a double hump that comes up, boom, boom, and then drops, probably the cable length is wrong, the loop coupling is wrong, there's too much dust, something else. So you test it before you go, and then when we modify, so let's go to a little different view, Mark, to your camera. And what I'm going to do is pop this up on the table, and so I'm going to pull these tuning lock nuts back such that I can get to the tuning rods. I'm going to move this from 450 down into the 440 ham. So are the resonators going to get longer or shorter, studio audience? Did I hear shorter? I didn't hear the answer. Or was
If
that
you're
a burp?
going down in frequency, they're going up and longer in length.
They're going longer in length. Thank you, Jim. So we're going to get so I'm running these stop nuts up so that I can go down. And I'm going to leave these rejects alone for now. So we're not able to get, okay, and what I'm going to go for our new parameters, markers. I'm going to turn off the markers. I'm going to go for 444 megahertz, 449 megahertz. I'm going to center my instrument, and you can't see what I'm doing, but you'll just have to trust me. 445 megahertz and a span of 20 megahertz. And now this thing is going to go and recalculate all the stuff. And boy, that doesn't look very good, does it? Because I've moved 10 megahertz from where I wanted to be. So I'm going to hop on here, and actually I'm going to make my span 50 megahertz for the time being so that we can see this thing coming in. So here's the next, and 455 megahertz, was that what? Okay, I'm just going to put a marker way up here. This is where we think this thing is approximately tuned. So, so this is the high frequency. So will this work in the ham band? So I took the first resonator way on the end here, and I simply ran it down such that I'm passing the high frequency and rejecting the low frequency. I'm going to do the same on, and Mark, why don't you zoom out a little bit on yours, and we could even go to single frame maybe, Dave. You can look at, so you can see what I'm doing. I'm now running the second resonator, and we said this is the high, so I'm trying to peak marker 2. Did you notice how this notch kind of moved with me? Because these reject sets the pass to reject spacing. They're not absolute frequency. This center resonator that I'm working on is an absolute frequency, and we can see it coming down, coming down. That's looking much better, isn't it? But I can't see what's going on, so I'm going to set my span to about 10 megahertz now. Now I want a little more because 10 megahertz is 5 up and 5 down. I'm not going to see all of my pieces, so I'm going to go to 20 megahertz. Again, calculating, so the instrument is staying with me so that I don't have to recal everything. And this is very quick and rudimentary, but I'm looking for marker 2. I'm looking, now maybe Mark, let's zoom in on the screen. I'm looking for marker 2, so I'm looking for how much does it, insertion loss, how much goes away, and I'm looking at the match. So you see how this shape is changing a little bit, but notice this down here, that looks pretty good up there, but it looks crappy down here. Oh, I'm going to use this screen. It's even easier to see. So what I'm going to do is, again, this is Al Capone's vault. This is the first time I'm looking at this thing to find out whether this Hamfest special is going to work on your repeater. So I'm actually trying now and experimenting. Ah, there we go. I was looking for this lower dip to get to where I wanted it. It's this furthest right cavity. And I'm actually ignoring the upper yellow trace right now. I'm just tuning for match. And then I'm going to look at the upper trace and say, is it good enough? And if so, I'm going to leave it alone. And if it's not
Are you just
good,
adjusting the one right now, Doug, or are you adjusting more than one?
okay. And I can barely hear you, Willem. You said, can you repeat the question?
What is it that you're adjusting? Is it just the rightmost one, or is it all three of them?
It's all three, and we're going to zoom out a little bit so you can still see. You can kind of generally see. So what I'm going with is on here, we're on the right half of the duplexer here, and I have 3 pass resonators, and I have 3 reject stubs. So what I'm doing is I'm starting, maybe I'll call these things the high side 1, 2, and 3. So I'm starting with high number 1 and adjusting this for the best return loss up here, which I know it's harder for you to see, but I can see that. So I finished with 1, getting it as nice as I can. Now I'm going over to 2 and getting it fairly nice. And now I'm going over to 3. And I have a 20 dB return loss. And when I look up at this guy, which is marker 2, I'm at 1.5 dB. What did we say when we took our notes, which is underneath my filter right now? We were above 1.5 dB. So we've actually improved the tuning. I have a reasonable shape, at least for the time being. And okay. So I'm not done yet, but I'm pretty happy with this for the time being, except I'm now going to mark, if we zoom out a little bit, I'm now going to, and what I need is some more dynamic range on this thing. I'm adjusting these reject, and you can, there we go. So I'm changing the spacing from the pass to the reject. And being that I don't have this instrument set up to see enough yet, I'm just going to kind of give them a gentle, I moved my notch down just a little bit, and I'm just going to temporarily tighten these things. And I'm going to, for the time being, finger tight these guys. So I know what you're thinking. You're thinking, did he tune 3 cavities or 4? And to be honest with you, I kind of lost track myself. So do you feel lucky? So I've tuned this half, but this half is still tuned up at 453. I'm at 449. You notice this really weird shape up here. I now have to tune this side. Otherwise, these things are in the wrong places. So I'm going to loosen these guys up. Because again, I'm going down, and I'm going to give them plenty of space because I'm going pretty far down. And we kind of believe that this will go down because this sticker says 435. So to Mark's question, I think we're going to be okay. So now I'm getting ready to make a rookie mistake because I'm talking and I'm not always thinking. I got to move the cables from one side to the other. So Mark, if you zoom out a little bit, they can see what I'm doing on your screen. And then we'll zoom in before we go. So what I've done is taken this one out. I'm going to put my dummy load on here. I'm going to leave it off for the time being. And then I'm going to show you when I put it on. So I'm going to this side. I still have my antenna. And I'm going to terminate this as Mark zooms into the screen. That's a pretty dirty picture. Now what I'm going to do is put this dummy load on, and you see how it changed? Here's back, not connected. Here's connected. So you always kind of want to do this with your dummy load on. This thing is all up here, but that's not where I want it. I want it to be down here, and that's why that shape looked so weird. So I'm going to, you can't see it, and we're not going to bother to pan, but I'm going down to the first cavity on the low side, and I'm going to lengthen it. And you can see it's, normally I would get my span a little further, but having done the first, I know what it's going to do. So there's an approximate peak on my low frequency. And now I'm doing the next, because I am tuning low, so I'm tuning marker 1 right here. And so before I kind of said, I'm going to tune for return loss. Right now I'm trying to get an approximate shape up here. So I'm tuning for S21. And then when I get something that looks kind of correct, now I'm going to go for return loss down here. Making sure that my shape up above doesn't, oh, that's nice. Oh. I swear this might be a duplexer by Binford. And remember, if you're going to buy a duplexer, always buy the Binford. That is a wonderful, now this is kind of a unique shape, and that probably says I should go back and forth a couple of times. But marker 1, look at the insertion loss, 0.85 dB. That's where I want to see it. And my guess is if I now go to the rejects, which is just below here, and I can probably shape this thing up a little bit. Mark, why don't you zoom us down. I don't know if they'll be able to see it all in here, but so here's my reject stubs. These gold, they're actually not brass, but probably a neutral temperature coefficient metal. But they're all approximately out the same distance. This sets the rejection to the transmitter or to the pass frequency. These are on the other side. So this sets the center frequency, and this sets how far offset the reject is. But when I look at this one is out maybe 3/8 of an inch, 1/2 an inch, and almost an inch. I don't understand why that's that way. So if we look a little closer at the zoom in, Mark, I'm now bringing this reject out and just bringing it out approximately to the same place. What I really need to do is, okay, there it's moving. I really need to set up such that I'm not bottomed out here. So apparently these, and this side does want to be this funky down, and I would expect 6 cavities to have a little bit more loss and more rejection. This is probably set up to handle a repeater up to the 150, 200 watt transmit level, which none of us need anymore in the ham bands, considering our challenge is always hearing on the repeater, not transmitting on the repeater. But so the answer to this question is, will this work on my ham repeater? Yes. We tested it. Where's my clock? Okay. We tested it before. It worked where it was designed to. We made an approximate notes for, how much transmit, receive, frequency, attenuation. And then we moved it down. So what I would do next on this thing is
Take the dust off.
I would clean the dust off. I would take it to the dry cleaner. And I know Mark has a dry cleaner here. He's got an air compressor out in his shop. It was running earlier, and he remembered to turn it off before we started here. I would blow it all out. I would take some Windex on a paper towel, which we had around here, but I'm not going to bother to do it. Just kind of get the dust off. I would check all of these. Mark, if we zoom out maybe and take him exclusively, go a little wider view. Yeah, so what I would do is dust it off, clean it up. I would check each of these cables to see, are they good and tight? Are they nice and tight? No play? These all do look good. If I was seeing a double humped response, I would be, oh, these are wrong. This guy looks nice and tight. I don't need to, this one is good enough, but if it's at all loose, make sure this junction, all the screws are down. Then I would go through and really precise. I would set up for more dynamic range so that I can truly see the bottom of the notch. Because as you'll see on this next example, we will be able to very clearly see to the bottom.
So on that, so when you take that to the site, you just throw it at the back of the truck and we go up the mountain. Is that going to change anything?
I'm going to throw it in the back of my truck. I'm going to put it on top of, I'm going to wrap it in some moving blankets. I'm going to put it, and as soon as I get this out, we'll give some color commentary. But are we on the wide view? So I'm going to wrap this thing in a moving blanket. I'm going to make sure these are tightened down. And then I'm going to set this, ideally, if it's a nice smooth ride, you can set it down horizontal, but I would prefer to transport it vertical, and I'll put it on the car seat because many of the sites we're going to, that'll rattle your dentures out of your mouth. Why am I doing it vertical? Because as I go to this filter, and this is another one that I brought that I figured if we were totally bored, we could go through, but we won't go through it today. This is the filter that came out of Calcon from the Kremling site in 2021. This is a VHF. You notice it's much longer. It's 3 feet tall. And the resonators in this thing, what's inside here are posts that sit here and hang. And they're supported at the top, but they're not at the bottom. They're just hanging in the middle, or in this case, you can see it really nicely. This resonator is hanging in the middle, down in the cavity. Well, at UHF, it's only about 6 some inches long, and the bottom is just covered over. On VHF, it's going to be 19 inches long. And if I transport this thing horizontal,
And I'm driving.
and Mark is driving, Mark is driving, it's going to be fine because he's a very gentle driver. He doesn't like to break his Jeep. But if John Maxwell is driving, he's only going to touch the top of every other rock as he's bouncing up this hill. This resonator that's sitting in here may start to deflect slightly. You may break the connection point up here, and now your tuning is changing. So this one we will retune and take out to the Colorado Connection site in Lyman. When we do it, we will transport it in the truck wrapped in moving blankets vertically. That way any shock on this thing as we're going over bumps is absorbed in the vertical of the rod. It's not deflecting it horizontal. That's a good question.
And then I guess I had another,
And I'll let you drive because you're nicer on the driving than I am.
except for on the short wheelbase. So the other question, so you've done everything here with the, a load and some things on this. All antennas are not necessarily a 50 ohm load. Are there some cases when you get to the site and you start looking for some descents and some things that you may have to touch this, or is that discouraged?
If you do, which camera am I on? I'm on this one. So I think I'm on the little guy.
Okay.
Tally lights. Willem, Maxwell, if you're listening, we need tally lights.
Working on it.
And so Mark asked, I don't know if his mic was on. When we get to the site, 50 ohms isn't always 50 ohms. Does he have to touch this? The bottom, my gut feel or my school of hard knocks answer is, if you screw with it, you're only going to make it worse. You can't make up for the sins of an antenna system with a duplexer. When I'm done tuning something, somebody will look at it and go, well, you're at 0.85 dB insertion loss, but I thought I saw earlier you had 0.84. And I go, yeah, you're right. I'm a hundredth off. You want to go back and change it? And I respond, no. We're only going to make it worse. I tuned it the best I could for forward, for insertion loss, for return loss, for reflected. Leave it alone. I really embrace, from The Simpsons, the Krusty brand seal of approval. It's not just good, it's good enough. We're getting into areas that are just so fine. We would never see the difference and the risk of screwing it up. So when you tune these things and they're all perfect, and that's really a lesson for a different session. But if you take one of the, do you have one of your 3-cavity DBs over there, Mark? Let me use a real example. This is a filter that I'll bet you Jerry Villauer that's on the call with us has one of these. I'll bet you some others, maybe there's one or two others that have one of these sets of cavities. Okay, I'm just going to leave this off. So this is a 3-cavity Decibel Products duplexer. You're sitting there saying, aren't most cavity duplexer 4 cavities, Doug? Or 6 cavities? Yes. This was designed for a repeater system that runs a minimum of 5 megahertz between the transmitter and the receiver and has additional filtering in its receiver. So they only put a 3rd cavity. You notice there's a spot and a hole here for a 4th cavity, but to keep costs down, they removed it. It says low frequency pass, high frequency pass, and okay, there's your trimmer. So what they're doing on commercial repeaters, usually the low frequency is your transmitter, your high frequency is your receiver. It's backwards to ham. Look, oh, well, yeah, backwards to ham here. So there's a T connector here, and 2 cavities from the T connector to 1 cavity. So this says 1 cavity is the high frequency, the receiver. 1 cavity, or 2 cavities is the low frequency, the transmitter. So if you're moving this a great distance, and there's cables between this, if I were to tune this filter, I would tune this 1 cavity at a time. I would pop this cable off, which is probably why it's loose, and I would set my instrument on here, and I would tune this 1 cavity. Then I would do the same thing. I would pop these off and tune this cavity. So I have a nice peak and a reject. Now some of you online are saying, well, this one had 2 connectors, the one I just showed you, the black one. This one has a T connector. And this one also has a little piston trimmer cap that's the equivalent of that brass-looking reject adjustment. This cavity has 2 ports built in. There's no capacitor. What's the difference? Well, this is the fundamentally simplest filter. It is what we call a pass filter. It has a bell-shaped curve. Comes up and goes down. The insertion of that filter sets the Q of the filter. If I've set it for very low insertion, it's a very broad, it's more like a pitcher's mount. If I set the insertion like this one is set for, 2 dB, that's a pretty lossy filter. It brings those in, there's more loss, and it looks more like the Matterhorn than it does a pitcher's mount. So you set this filter for your frequency. And we had an RMHAM-U, and there should be something in the archives on filters. And if you guys really want one, we can do one again in the future. If I take away one of these, so this is called a pass filter. If you take away one of these loops, take it out of the circuit, or just, you can even run it with an empty hole there temporarily, and put a T connector on the top of this, like we had over here. This, you know what a T connector looks like. It looks just like this. What this does is it inverts that pattern. and it becomes a reject only cavity. So RF goes in, and when it hits the resonant point, it says, ah, resonance, and I'm going to suck that frequency out, and then it comes back up. So it's an inverted Matterhorn or an inverted pitcher's mound. You set for minimum coupling here, you're going to get the inverted, you're going to get the Marianas Trench. You set it for the other way, you've basically dredged your channel in the canal. So that's a reject cavity. When I have one of these on here, I have a T connector, and I have this little piston trimmer, which you can't see in here. This becomes a band pass, band reject. You get a very low insertion pass. You get a very deep reject, but off your channel, but that's only at 5 megahertz from the transmitter to the receiver. When you go 6 or 7 megahertz away, this, I guess I can sweep this, and it's going to be wherever it is. I'm not going to try to adjust this one because I think we're starting to get short on time. Do we still have any viewers, Dave, or has everybody gotten so bored with me? Oh, wow. If you guys believe all this, I got a bridge to sell you. No. So here, Mark, you can zoom in on the screen. And this was obviously tuned in the ham band. And it looks like you did a pretty good job. Okay. So, and I said I wasn't going to adjust it, but you notice here's the pass. There's the reject. I said the pass to reject is the spacing of is the setting of this capacitor. So when I move the pass, you notice the reject is going with it. So that is about ideal. But so you're a little off on your 5 megahertz transmit to receive, but you did a good job tuning this.
So is there a particular order, though, this filter you had not seen before, or do you just kind of touch the settings to see, or do you, is there kind of the first?
So what I would do if you zoom out a little bit, and I said I wasn't going to do it, but what I'm going to do is take this guy out. And so yes, what I would normally, oh, I'm pulling the wrong one. I want to pull this. And then, so I set this first one, and it's really a little out of tune. So here, what I'm going to do, marker 2. I'm going to try to get both of these. You're just misaligned by about 100 kilohertz. You did great on this if it was just an experiment. So that's what we've got. We've got marker 1, 0.6 dB, marker 2, 40 dB. So remember those numbers, or I'll write it down. 0.6 and 40 dB reject. Okay. And the match is damn good. So now I'm going to go over to the other of the two cavities, and I want to see the same thing. That's, however this loop and connectivity inside is done. Pretty good job, Mark. And I'm just going to give this, okay. Now, my transmitter is at my intended frequency, 1.2 dB, and my reject is closer to 30 dB. So not quite as, but acceptable, but not quite as good. So I'm going to set this using my return loss. And, okay, 1.2. 1.2 and 30 some dB. So when I add this cable in between, ideally I'd like to have only double the insertion loss. I want this to be additive, and I want to get all of that rejection. And I don't want to see a double humped response. Because if I do, this is not right. And we're close. So I said 1.2 and 0.6. That to me says about 1.8. I'm getting 1.9. There is a little bit of loss in this cable. Some people will say, oh, connector, you can lose 3 dB. No, if I was losing 3 dB and there was 100 watts going through this, I would be dissipating 50 watts of heat. This connector will explode. I haven't seen any exploding end connectors recently. So this looks pretty good. If I were to borrow, and these are tightened down, if I were to add to this cable length, you would, well, let's see if we can do it. Because this is an area that I frequently have people questioning and coming to me, and we're going to see as we wrap up with the other filters, because we're going to kind of go into a speed round for isolators, mobile duplexer, and bandpass filters, and then finish this up. Okay. Okay. So we can see on our screen, this looks pretty darn good. I'm going to go to this really long random length cable. And if this wasn't all bolted down, I might even try that one. What do you think it's going to do? Huh? It's not bad. But my insertion loss went up to 2 dB. So I have more insertion loss, and it's not quite as clean. And the frequency is shifted a little bit where it's tuned. But if you saw it come up and then drop, you'd know this is not right. So that's big duplexer. So this would work, but what would work better? This guy, 3 cavities, or 6 cavities? Well, if you're running this on a little backyard 10-watt repeater, you've got enough isolation in here. But if you're going to try to run 100 watts and you're going to put this on one of the biggest mountains around, I wouldn't recommend this. I would recommend a little larger unit with more filtration. But, which gives me a segment to mobile filters. And so this is what we're setting up for here. These are 2 sample Chinese import filters. And Dave, if we can go to the camera 2. Look kind of the same. Little different vendor, but you never know with China. This guy is the J Nuoda duplexer, Guangzhou, 462.0, 467.0. So a 5 megahertz split. Or is it? This one by, I don't know, JIESAI. I've had a number of these, and this off-brand is very good. This one's tuned to 441.7, 446.7. So this was actually ordered by somebody in the ham band. So we'll pop our little connectors off. We'll do a quick look into this thing. And come on, Tonto. You know, the Magic Man trick works better if we're paying attention. My camera operator was distracted. Okay. So if we look at our screen, and we're going to be one marker at 441.7 megahertz, and another marker, if it's 441, it's going to be 446.7 megahertz. We're not right in the middle of the notch, but it's generally kind of okay. The return loss is, yeah, generally kind of okay. Let me look at the other side. This should flip. But did you notice it changed a lot more as I put this termination on and not? I just don't have a lot of cavity here to work with and to keep it clean. So these are decent, but here's why you've got to be kind of careful with these. Band 50 megahertz. And we said our marker 3 was our commercial repeater. Here's our commercial repeater. Really great at the ham bands, isn't it? Very little insertion loss, lots of rejection. And the commercial repeater at your site is 30 dB down. So you've got a tower, we've got a couple antennas. I'm going to go to a description for a minute, Dave, here. They're busy. Okay, you can just listen. We've got a tower, we've got 2 antennas on the tower, and so let's say we put those antennas right next to each other on the tower. I'm running, that commercial repeater is running 100 watts. How much is this filter going to protect me? Well, it's going to be down about 10, 20, 30 dB. There we go, 30 dB down. So that 100-watt repeater, assuming it doesn't have any filtering at our frequency, which I can't ignore that, but I am for now, just to make this easier. 100 watts down 10 dB is 10 watts. Down another 10 dB, 20 is 1 watt. Down another 10 dB is 100 milliwatts. So I'm going to have 100 milliwatts of that repeater coming down my cable. Now I have antenna to antenna spacing. So if it's horizontal, I'm maybe going to get 20 dB. I don't, you know, there's formulas out there. So my 100 milliwatts, which is plus 20 dBm, is with the spacing is maybe down to a milliwatt, 0 dBm. My receiver is trying to run down to minus 120 dBm. A lot of power coming down your throat because this filter has a lot of transmit to receive rejection, but not a lot out of band. And as we go even higher, we tested a best case, a 450 meg repeater. What if this repeater is really, well, it probably wouldn't be transmitting any higher than 465. I'm only down, what, no, it's more than 6 dB, but my calibration's a little messed up here with this stuff, but I'm down maybe 10 dB. What do I need? I need the big bongo drum here. This, okay, I'm on that camera. This will reject, put this in my receiver line, and all of this stuff goes away. So this is not a bad filter. And what are we on time? So I'm going to start to wrap this up with, what about this other filter? This is a filter that I ordered in from China, and I got it. It was just on random frequencies of 462, 467. But I rejected it, and I actually talked to the manufacturer, and I said, I reject this, don't want it. And they said, well, what if we just give you your money back and you don't even have to ship it? And this filter was not as advertised. So I'm going to 462, 467, I'm going to center myself at 465 megahertz. Come on. I'm going to span of, I don't know, yeah. Go to 20 megahertz. Okay. I'm going to put a marker. This is listed at 462 megahertz. Another marker at 467 megahertz. And marker 3 I don't care about, so I'll just get it out of our way. Come on. Okay. Marker 1, 462, marker 2, 467. There are my markers. This is my insertion. This is not a 5 megahertz duplexer, 5 megahertz wide. So let me move marker 1 kind of to the middle. So 463 and a half. $473 and a half, and I'm down to about 1.1. This is a 9 or 10 megahertz transmit to receive split duplexer. This thing is useless. This thing, useless in the ham band. Where am I, over here? Not all filters are created equal. Other than a little size difference, they both have all of these cables in here. This one has similar cables in there. But the way it's configured inside and the cable lengths, 9 megahertz, 5 megahertz. Another clue to filter 5 megahertz apart, you need bigger cavities to keep the loss down. That was one of the signs. It's not an exclusive, but there are small 5 megahertz, but they have more insertion loss. That was a clue. So, so if you came to me at the Ham Fest, and I guess I'll go over to this camera here, Dave. If you came to me at the Ham Fest with this and said, what do you think? Kind of like Tristan did at the NCERC Ham Fest, I would say, well, it's labeled 5 megs. It looks fundamentally good. But did you bring a VNA? Yes, I did. Did you bring the cables? Yes, I did. Did you bring the guitar pick? Yes, I did. Did you bring your 50 ohm load? Yes, I did. Then, and that's exactly what I did for Tristan. And when I put it on here, I said, Tristan, this looks horrible. He goes, yeah, I thought so too. And he told me what he did. The guy's really smart. And I was like, yeah, that's right. When I looked at this more carefully, and if we get it up into the sky, you can kind of see the center connector comes in, and it's right in the center of this unit. And if we really zoomed in on this, you would see all of the cables go left and right of this center line. The unit that Tristan had was actually 4 cavities and 2 cavities, and only upon deep inspection did I notice these cables go into the second to third cavity, not the third to fourth. And what clued me into that is as I'm sweeping this thing and I'm adjusting these tuning, why isn't this changing? And I more saw it becoming a reject than a pass. And that clued me in. Look at this thing. Ah, Tristan, here's the problem. And as soon as I told him that, he was like, I got it. We didn't check that part. So I think Dave had a question. I saw the microphone going up.
Yeah, I was going to point out, you've talked and provided a couple of examples about the out-of-band protection that you don't get in the simpler duplexers than you get with the additional your bongo drum there and the additional pass receiver protection. And
Yep.
I mean, you do need that kind of protection on transmitters too, so that to minimize intermod. But I have an example picture that I wanted to put up of a typical site installation. Notice all of
we
the.
know where that is.
I do. That's my antenna on the right hand end of that picture.
Yeah, on El Dorado Mountain.
On El Dorado
That's a
Mountain.
Colorado Repeater Association site. And for those listening online that are thinking to themselves, this is really great, and I'm going to ask all these guys, can I put my repeater up there as well? CRA pays over $200 a month to be part of that mess. And if they ask to add one more because of all of that stuff, their rent's going to go up. So don't hit us up for free rent.
It's
yes, Dave.
the
So
out-of-band protection is really important in a site, especially in a site like this. Those little 6-cavity, I've always called them mobile duplexers.
And that's what it is.
Just do not have the protection to not only allow your repeater to operate properly in a site like that, but so that you don't cause intermod to other people on that site because you don't have adequate protection on your transmitter.
And that is a
So-
great lead in to our final topic of the night. We're going to talk a little bit about isolators or circulators. Here are some examples. Here's one on a panel that's known as an intermodulation panel. Or this one made by Microwave Associates says intermodulation suppression panel. So one way of trying to keep interference down is we rely on our filter to do everything. And we want to put these pass filters, because we just went through the example, 5 megahertz away, I have very little rejection. With this bongo drum, we get a lot more because it's a steep bell-shaped curve, but it is what it is. So how do we get more? This is a small size isolator, and I'm going to move as we get into the dessert phase of the menu here, I'm going to move my main course over and go to these guys. So I'm going to, I know this one's capability, so I'm going to start with it. So I'm going to hook this thing up.
So Doug, what would you use an isolator for?
That's where I'm going.
Okay.
Well, thank you for asking, Dave. So this is a circulator. This is an isolator. Did you see the difference, what I did? I simply put a dummy load on one of the ports. This is a 3-port device. It's actually labeled 1, 2, 3. What am I, that camera? 1, 2, and 3. Inside of this is a piece of ferrite material. There are magnets. And I want to point out on the back of this, caution, magnetic device, keep 2 inches away from steel, iron, or other magnets. Why did they do that? Because there's ferrite, there's magnets, and whatever radio energy you put into port 1, you can see the arrow goes through to port 2, and it goes out. Whatever comes into 2 goes down to 3, and it comes out. And if I didn't have a dummy load here, anything out of 3 is going to come up back to 1. So when I put my transmitter on 1, all the power, or minus the insertion loss, which is relatively small, comes here and goes out to port 2. And if I have a bad VSWR and reflected power comes in, it comes and it goes into this dummy load. This dummy load is a 35-watt dummy load. On this particular, this is a 100-watt dummy load. So if I had a 100-watt transmitter going into this thing to my antenna and things reflect back, that full 100 watts is going to go right into this dummy load, which can handle it. I'm not going to hurt my transmitter if I disconnect the transmit antenna. Protected. Likewise, I'm going to use the other one because it's a little easier to hold. Any bad signal, like in the example, this is on a ham repeater, and we've got a commercial repeater at the same site. Maybe their antenna is very close to us, side by side. We've seen this. All of their transmitter energy is coming back, and if you don't have something like this, their energy actually goes, it's kind of like you got a car and they're pumping stuff into your exhaust pipe. And there's no one-way valve to keep it. So all the RF energy goes through and it sees your power amplifier, your transmitter, and says, that's a really big RF circuit that amplifies. And you end up amplifying the unintended signal and sending it back out. In this case, it all comes in and goes down to this dummy load. So this little one that I put on is, all the difference is this is only an isolator because this dummy load is not removable. It's fixed onto here. This one happens to be removable. So why would you use a circulator versus an isolator? Circulators are more used like at microwave, where you got your transmitter, you got your receiver, you've got your dish. You don't have things reflecting back, and you can kind of use it like a full duplex switch. But for us, you put this on, it's going to be an isolator. What's in here? Piece of ferrite, some magnets. What causes this to only go from here to here? I would need a multi-day lecture from Dr. Schroeder on here to say what the fields and waves magic is. But as I said, there's magnets in here. You put this next to a ferrous piece of metal, you're going to detune the magnets and you're going to detune the performance of this. Now, there's no user serviceable tuning on this one. This is all internally tuned and you can't change it. This one you notice there are holes where there's adjustable capacitors in here. So you can actually optimize this for your frequency. And I once asked a PhD back in New York at GE's Research Center, who was also an adjunct professor at Rensselaer Polytechnic, what's the theory of this working? And he said, I don't know. I got an explanation from one of the other PhDs and I didn't understand it. And at the end, the guy says, just think of it as magic and trust me and measure it. And we did, and it works. I've taken it on faith since. It's an RF diode. So we're looking here at this example. I'm going to center it, now I'm going to go to 450 megahertz. And I'm going to span across 100 megahertz. I'm going to transmit out of here and listen in here. And you will notice that, and I'm going to change my markers to, let's say this is a ham on 449 megahertz. And I've got I'm going to put marker 4 up here, 465 megahertz. I got a commercial repeater. So, okay, there we go. So there's our ham transmitter. There's our commercial transmitter. I'm looking at return loss down here. We're 10, 20, 30 dB down. There's a real nice match there, but it's good enough. I'm looking at S11, which is what's the insertion, what's the match going into it, and I'm looking at S21, what is going straight through this device. I only lose 0.4 dB in exchange for isolation. Now, if you have a nano VNA, you've only got 2 ports, and it doesn't have the ability to flip-flop back and forth. But what I can do with my nifty machine is go to my channel 1 up here, and I'm going to tell it, instead of doing S21, do S12. So I'm going to, in the machine, flip these 2 ports at the push of a button. Look at that. What are we looking at now? So instead of 0.4 dB going through, my signal is down 10, 20, 30, 40. I guess I must be at 5 megs per division. It's saying 22 dB, 23 dB. Did I change this thing to? Yep, I'm on 5. So let me go to 10. And that, oops, oh. Okay. That's why we had limited range, and I wasn't seeing on these duplexer all the way down to the noise floor. But I now have 20 dB on this little cheap device of rejection for things coming back. Mark, I can zoom out just slightly so that you can see this quadrant. Okay, that's good. So we could make it big, let's not worry. So I'm going up to my measurement button and saying, I'm right now looking at S12. What's coming in here? And you notice these things were just off screen. Maybe you could just, okay. You notice these things are blinking back and forth where that's saying it's working across the instrument where, okay. I'm looking at these things, so S21 is going through this way, and with the arrow, 0.4 dB a loss. S12, I have 23 dB, 24 dB a loss, which says that's really isolation. Can you do the same measurement on your nano VNA? Yes, but what you have to do is take this thing out change the connectors and put it in backwards to do it. You spend an extra $4,000, you can do it at the push of a button. That's the nice thing. So I'm going to put this big isolator on, and I think we'll see we've got a little bit more. This was a cheapie, the little silver one that I had, and I bought them for a particular reason, and it was enough. So here you go. We have a little less loss, 0.3 dB, nice match. It's very broadband. And when I go back the other way, I'm at 25 dB, which I think we were a little bit less. And I haven't even tried to tune this thing. So that's isolators. And we've talked about tuning your duplexer if we move to camera 1. There we go. We've talked about sweeping your antenna. We've talked about optimizing, trimming with this little guy. We've talked about traps, tuning a duplexer, the difference in a big duplexer and a little duplexer, and when do you need an isolator. All of these things are useful stuff you can do with your network analyzer. You could do it with a big guy like I've got, a little guy like a Nano VNA. And if you had a spectrum analyzer with a sweep generator and a directional coupler, which we didn't get into here, but if you have a spectrum analyzer and it has a tracking generator, you know what a directional coupler is going to do. That's what's all built into this box with the switches around it, so I can simply punch buttons. But I could do the same thing with that other equipment. I just need a little bit more time to calibrate it and switch it all around. So that's my summary of 3D printing. We look forward to getting James Sizek back. Are there any questions before we close this out?
To tie 3D printing into your presentation, Doug, on your 40 meter kit, them little plastic pieces that you said get real brittle when you try and pull the shield off, 3D print them if you break it to replace it.
Yep. Okay, thank you for that tie-in, Jim, because yes, that's, for years and years, we've done really deep RMHAM talks, and they've been great, but now I think we've had enough that hopefully you've enjoyed this, and we need to do more application of what we've learned. And so that's kind of where we're going. Any other questions or?
I just have one follow-up. When we were taking the break for the eclipse, I ran downstairs to see what the stuff is that I have for that bond. And the aluminum stuff has zinc in it, not copper. The copper
Aluminum and
stuff
zinc,
is
and
for,
that should be neutral. Yes.
right. The copper stuff is just for grounding, and it specifically says it's just copper to copper.
For copper to copper only. Perfect. And I don't know about you, Willem, but did you take a break for the eclipse? Because I took a break and got an eclair. That's what we were supposed to be doing, right?
I did refresh my coffee.
Dave.
And before we go, sorry, Willem, go ahead.
No, go ahead.
I was going to give everybody a glimpse behind the scenes. That's the room we're sitting in. And the rest.
Dave, you weren't supposed to tell him we're not at the top of the tower.
And,
Come down from the tower.
and the rest is magic.
And I don't know if they have a handheld camera, but what I'm looking at as I look over here is they have a monitor so I can see what the air product is. Okay, there we go. So I'm normally looking at this camera here, but I'm watching this monitor here, which in the future, if we can get that kind of behind the camera, but that's why you may have noticed I'm periodically turning my head because I was trying to see what you're seeing and not looking at mine. And then they have two very large, I think these are like 30-some inch wide monitors, two of them, and with a lot of technology. There's you can go back to that.
I want another camera so I can have two cameras.
Yeah, but no, yeah, there we go. So they've got I can use one of my pointers, a relay rack full of wireless mics and pieces. We've obviously got lighting. This is my monitor, and you can see the two. And then massive switches, video, audio switch, other pieces. It's quite the setup. They've worked very hard on it. And definitely accept our thanks, because without this, we wouldn't be doing these sessions. So, and the other thing that they need is tally lights so that I can see they moved over to this camera. Oh, they have a tally light. It's way down here. So,
So
any other
actually,
questions before we go find some lunch?
Here's the new tele light. I just need to get it programmed and integrate it into the system.
They moved over here.
Can
Okay,
you see my picture?
we can't see yours, but
It's-
oh, ooh. Is that a commercial product, or did you 3D print that with something in it?
It's a little M5 micro computer that has all kinds of things like Wi-Fi and whatnot built in. And if I turn it on, you'll see that it's got a little color screen, and as long as we program it correctly, this is going to become our tele lights once I get around to actually whoops, sorry, that's not good. Get to program those properly.
And how many slices of key lime pie is that going to cost me?
At least one.
At least one. That's a fair deal. For those
one
not-
pie for each tally light.
Oh, for those not in on the joke, Willem really likes key lime pie, which I like it, but it's not my favorite. But I know that's one of his favorites. My favorite is actually his wife's favorite, which is strawberry rhubarb. So when Willem goes off with his key lime, I'm more over on the other side of the field day site with Kathy having strawberry rhubarb. So, but and Willem always tells us after we say, "Oh, you're going to write some software? How many pies is it going to cost me?" So yes, good old key lime pie. So, well, thanks all for joining us. Willem, do you have any closing comments as our
No, I was just
Chancellor
going
of
to say
Education?
thank you for stepping in at short notice here and filling in the spot. And also, of course, thank you to our AV team for everything they did today. We hope we'll see you all on November the 11th for our next RMHAM University, which will be on programming DMR radio. So that's presented by Conga, K0NGA, Mike, of course, and then we'll have a follow-up on that in December by John Maxwell and Tristan and somebody else. I don't. K0WSU. That's going to talk more about the back end of our DMR system. So some interesting things coming up. Hope to see you all there. And with that, thank you very much, and we'll see you again soon.
And Willem, just to confirm everything, the next session will be in person and online.
That's correct. So we're going
Yeah.
back to the Cherry Creek Education Center in, well, I guess that's Greenwood Village.
I think I don't know what town, but yeah, Cherry Creek Schools. And thanks everybody for attending. We're going to be out of here and play the NFL music and the promo. Earlier this week, when I was out at Folsom Field for CU, I saw the Aflac duck out there and they were doing their commercials. So I'm just going to say Aflac, and we'll see you later.